recording. Hey, what is the agenda? Who's got stuff?
If you guys don't mind me piping in, I am pretty sure that I have an idea for how we can do modulation of audio unit parameters. And
Nice.
the way that it could work is completely on the Swift side without a timer. And the way it would work is just using one of the AV source nodes. And each time in the block, you get the current time. You send that to any like low frequency oscillators you have to update their values. And then after you've done that, you send a callback to something that knows about the audio unit parameters. And then those are fed those values. So I've been testing this and I've got it to work. And as far as I can tell, like I've got 4 modulations going, 4 different parameters, like unrelated to each other. And it looks like it's working. So it's good news.
Yeah, show us more.
Yeah, so if you guys want me to share my screen, I can show you just a little bit about it. I don't mean to own the session here. I just
No, that's great.
Update you guys since we kind of dove into that last time. So I'll just run this. Oh, it's going to my iPad. We'll see if you guys can hear it, and then I'll talk about the code real quick.
When you get to the code, you might want to make the font size a little bit bigger.
Yeah, sure. You might have to tell me how. So any second now. Can you guys hear that?
Yeah.
So that's just pushing around an oscillator's frequency while pushing around a low pass filter's cutoff and resonance. And basically the way it works, like I said, it has some kind of source node, which is just this AV source node. Here, let me get the font bigger. Can I just hold down Command and like?
Command Shift Plus should do it.
Command Shift Plus.
Unless that's not an Xcode.
I know that I can do it in preferences. I just didn't want to take you guys through this. Did I just do something?
I think even just like Command
yeah,
Plus might work.
Command Shift Plus should work, yeah.
There we go. Do it again. Do it again.
Oh, there we go. Okay.
There's also the presentation mode in the
Right. Yeah, if you do Command, comma, you can bring up preferences.
Paperclip in it.
anyway, really good.
Does this look good to you guys?
Yeah, I can read it.
Okay, cool. So basically, there's going to be some kind of like manager of LFOs because there needs to be multiple LFOs. It's going to seem a little bit more complicated than it really is just because it's like a many-to-many relationship between LFOs and audio unit parameters. But to put it simply, you've got this source node that just like knows about the audio stream. So it gets updated based on this sample time. And again, like there's a little bit of bookkeeping here that'll make it seem more complicated. You can kind of ignore this start time. So basically, you've just got some kind of like time that you know of in this source node. It's connected to the audio stream, and it's going to get fed to these LFOs. So to go to what an LFO is, it's basically just this lookup table oscillator. So the only thing that really matters here is you've got some kind of calculate next lookup value. And this basically just takes the time and finds some kind of value within a table, which this LFO has. That's basically, I mean, if you're familiar with the table, it's nothing more than an array of floating point values. So we're going to look up what the next lookup value is for this LFO. There's a little bit of extra work in here. I actually, the issue that I was having that I was posting about in Slack was this like linear interpolation that I was doing for when I arrived at values in between index values for the lookup array. If it ended up being right on an index, it would throw off everything. And I didn't realize this was happening because in my mind, it's like never going to hit the 0, but it would. And right on every time it would happen, I would get all sorts of weird errors. And with anything that was generating noise, like an oscillator, it would just cause chaos. So it seemed like an AudioKit problem. But anyway, this piece of code right here fixed it, which pretty much is stating like, is this an integer? If so, just grab the table's value at the index, which you can pretty much think of that as what this does. So this whole thing is just going, I'm going to go grab a value from the table.
Right. Well, you should be able to do that without that logic right there. I mean, at least it's, you know, in other places, I'm sure, around AudioKit. But I just wanted to see where you're actually setting the AU parameters and sort
Sure.
of the call, you know,
Yeah.
I'd
So
really like it would be great to just put it in the debugger and see the whole stack.
okay.
But anyway,
so-
you can tell me first.
Yeah, I'll bring it to it. We're almost there. So after it gets the values, it's basically just updating a value that's going to get grabbed later for each of these LFOs. I just call it lookup value. And then once it's all done, I'm going to call this lookups complete handler. So that's going to get fed up all the way to this thing that I call the Modulation Manager, which is kind of like the glue between I've got many LFOs and I've got many audio unit parameters. So there's going to be a lot of bookkeeping between that.
What thread is the you know, the source node callback called on?
I honestly have no idea.
All right, let's turn on thread sanitizer and see how much this blows up.
Yeah. Hey, let's figure this out together, because I hope that there's a way that we can figure this out together. So anyway, eventually there's this manager that connects all these classes that I call modulation. And what they do is they've got each modulation has many targets, because of course you're going to have something moving at a frequency, changing a value. But that is being applied to many different things, like an LF or a cutoff of a filter, the frequency of an oscillator, whatever. So a lot of that, just kind of accept that that's the way it is, just so I don't waste too much of your time. But basically, I've got this function inside here called Modulate Matrix, which is going to end up doing all of the setting a AU parameter to what I've determined as the parameter value. There's just quite a lot of bookkeeping in here, so I don't want to waste too much of you guys' time to talk about it, because there's, you know, certain ones are like logarithmic range AU parameters. I keep track of what the original value is, which I call an anchor value. You can think of that as like, where is the knob currently pointed whenever the modulation starts? Because there's like, here's where it's pointing, and then there's some range that it's changing the value in between. But yeah, anyway, so within this Modulation Manager is where I'm going to set the value. And basically that Modulate Matrix function that I called out is just where, when my LFO manager says that we've got all the new lookup values ready, then I call Modulate Matrix. And Modulate Matrix is just that thing that says, let's go through all of the audio unit parameters that we need to modulate, and let's get new values from the modulations for them, add them all up for the parameter, and assign a new value. So I'm sorry if that seems like a lot. I don't know how to get through that quicker to explain what's going on. So that's
Well,
the idea.
shall we try the
I don't
thread
think it's that
sanitizer?
complex.
Yeah. So I'm pretty ignorant here. So where do I go from here to try and figure
Oh
this out?
yeah. So what do you call it? It's like click on where it says audio recipes up there, and then you should
No, in the what's it called? The scheme.
yeah.
Oh,
Yeah.
okay.
Okay, edit scheme. Go to diagnostics
On the right.
and thread sanitizer.
Guys, should I be nervous right now?
Sure.
Yes.
Yeah. Hey, I mean, you were making some noise, so
Yeah, it's cool.
like, listen, if you ran synth1 and thread sanitizer, I haven't done it, it would explode thread sanitizer. Thread sanitizer would blow up and say, I cannot handle how badly you programmed this.
I thought Synth One was done all in one audio unit.
It is, but there's a lot of, and I try and communicate to UI and DSP through the circular buffers.
Yeah.
But I've become so much more aware of thread safety because of you, really, in these office hours. In hindsight,
I'm
I'm
the pain in the
afraid.
butt thread safety guy.
I love it. I mean,
That's all I am.
I love it, and I just wish I knew, you know, or was aware of issues or dangers now, you know, back then. But I guarantee you, Synth One would just
Yeah.
make it blow up. There's just no way.
Well, this is just a bunch of auto layout stuff. There it is. Thread sanitizer. Oh, look, wait, does it, so, okay, so anyone involving your code, if you look at those stacks,
You're gonna have to lead me.
well, just scroll up to the top, I guess, for when you started it. We'll just look at the
there's-
very
There's
first.
quite a lot here.
Okay, so that's the top.
Yeah.
All right, so LFO manager, add LFO. Yeah, so, I mean, without even really looking at this, I'm just guessing what's happening is that, you know, that source node is called on some thread, and that's not the main thread. It's some other thread, I think. And so you've got communications just willy-nilly between threads, basically. Like there's what I keep saying, and I'm sorry I'm a broken record about this, but if you're not using thread primitives, thread safety primitives, those include mutexes, you know, locks, semaphores, you know, or in our case, really what you should be using is a lock-free, you know, circular buffers or whatever, then it's not going to be correct, which means it's going to crash eventually. So you can't say, like earlier one of you guys said, hey, well, it makes sound. Well, yeah, it makes sound. And you can do a lot of like thread stuff that, you know, thread unsafe code that works for a while, but then you run it for like an hour and then it finally crashes. That's what's so insidious about threads, is that a bug does not appear, it's probabilistic, right? So everything has to, the stars have to align, and then the bug happens.
So Taylor,
So-
I have a question. I have a question for you, because I've been, you know, been following along the last few office hours. Everything that Matt's showing us is at the Swift layer. Like we haven't even got down to the you know, C++ layer, and the tools you're describing are all at the C++ layer. So what can be done at the Swift layer?
Yeah, well, actually, they came out with a Swift Atomics thing recently, and
I mean, I think
you could abstract, like you could wrap some of this out to Swift. You know, like you could wrap a circular buffer so it could be used from Swift.
Taylor, can you help point out like where we might see, you know, like where would Matt look? I mean, because I know where to look, but like I'm wondering, like, how does Matt know, or how does Marcus know what thing that they make in Swift is going to create a separate thread? You know, because it feels like that should be pretty well documented in a given framework. So it's kind of like
callback of the source node. If we just put a breakpoint, I mean, so
the internal render block of
LFO,
source node, is that what you're saying?
Yeah, it's this.
That's what I'm just saying. Like yeah, we gotta make it clear for everybody so that
Well,
they know
I
where
can-
they're gonna step off a cliff, right?
Yeah, if I can answer and talk about it. So if you scroll up a little bit, then you'll see this callback. Keep going. It's the callback for the source node equals, and you create this AV source node, and let's put a breakpoint in there. Just put a breakpoint there and run the thing. Yeah.
Just anywhere, or
Yeah, that's fine. That's fine. Somewhere it's gonna hit. All right, so what thread are we on? We're actually, look, we're actually on the IO thread.
Is that good or bad?
Well, it's good in a way, but it just means you're communicating with the audio thread. I mean, that is the audio thread, I think.
Right. Yeah. I mean, to be clear, like this whole thing is a node, and I connected just like an AudioKit node. If I can jump through my mess here, I connect my Modulation Manager to a mixer just like I would, any other thing. I've turned my Modulation Manager here into a node, which all I return is the source node, essentially, is what inevitably goes up the chain and gets handed. So yeah, I mean, this source node is on that audio thread.
Sure, but lookup's complete handler ultimately sets a bunch of AU parameters, right?
Yes.
Right. So that's not then you're calling a bunch of stuff that's not really supposed to be called from the audio thread. I mean, it's
But how would you ever break that barrier then? Like, is there even like a best practice there? I guess is my confusion here. That's where I can't figure out.
Would dispatching it help? Or, I mean, it wouldn't be sample accurate, but would it get past the thread issues?
Well, I think then you'd be in a real-time safety issue. And also there's probably real-time safety issues with this too, because it's calling into like Objective-C and stuff, probably.
But it's only setting values to it. It's not going to like miss a. It's not going to.
Well, who knows exactly what the side effects of all this is, and when you set those parameter values, that can kick off other things. I mean, it's just not supposed to be like there's those callbacks, right, for when parameter values change that you can register. So yeah, I mean, I could be wrong about that, but
is there a way to just do this asynchronously where like every time the lookup complete handler happens, it just tosses it away, and then like it can't affect the audio thread? All it's doing is saying, go figure out the values, and I hope you do it in time, type of logic.
Yeah, I mean, you can you could do something where you put all the modulations you want into a circular buffer, and then you have the main thread looks for those periodically, like on a timer, and then it's not very good. It's not a very good way to do modulation really that way, because you got all this latency as it goes across the circular buffer. The main thread is only going to be called so often. You don't want to pull all the time. Yeah, this stuff is it's tricky.
I mean, to me, it seems like there's still a place for this, though, because like this is something that's hard to do in AudioKit, and at least this does it.
Well, yeah, I mean, it's hard to do in AudioKit because AudioKit has the same. I think we talked about this last time. It has the same kind of design as AV Audio Engine, and AV Audio Engine isn't designed for this kind of thing either. I mean, I really think the best you could probably do if you really want it in separate units is to abuse the audio connections as modulation connections. So send control signals along your audio connections.
But you'd have to build that out in every single thing that wants to accept the modulations,
Yep.
right?
Yep.
That sounds crazy.
Yep.
Right? Like that would be a monumental feat. Whereas
Well, I mean,
like this
well,
thing,
wait. It would be monumental if you need to modulate a lot of things, which it looks like you do. Like if you just needed to modulate a few things, you probably could pull it off.
Well,
Right.
he's saying it would be monumental in changing everything in AudioKit to be able to do that, right? Is that what you meant?
yeah,
Yeah.
like anything that you want to modulate, you would now need to handle this incoming floating point stream and be able to apply it if you're like to the whatever the things are that you're trying to do. Like,
Well, I mean, it is kind of orthogonal to. Again, I don't think this is a very good approach, really. So I don't want to defend it too hard, you know. But it can be kind of orthogonal to other stuff. In other words, you can just kind of add. Let's say you want to add it to some node. You want to, let's say, frequency modulate your oscillator. Well, you can add just an extra bus, I think, and you don't necessarily have to connect it. You know, it's just your modulation bus, and that would go in. I just don't like it's not what this is intended. It's not AV Audio Engine was not designed to do that, really. It's not the intent.
but how do you like do automation of audio unit values? Because that occurs like rapidly from outside of an audio unit value, right? Like
Correct.
if you're doing like a curve that you're automating, you are just blasting values at that audio parameter.
Not really. So the way it works is that it uses ramps, and really you tell it ramp, you blast, but you don't even blast. You just send ramps at it. And so what we do to do curves is we break the curve into a bunch of little ramps.
Okay.
Sort of the assumption is that you're not doing like crazy modulation, like on a synth, like an analog or virtual analog synth. You might have your LFO running, you know, I don't know, 200 hertz or something, you know, and you probably wouldn't draw in a 200 hertz automation curve, right? So it's not designed for like high frequency kind of, certainly not audio rate modulation, and even like, you know, sub audio rate modulation. It's not really what it is. But I mean, I would love it if they designed it in a more like modular synth kind of perspective, but it's more of a like a DAW kind of signal chain type of thing.
So I want to make an observation, because I feel like what Matt is going for is a super common use case. Like every synthesizer has a modulation matrix. I
Yep.
feel like there's a conflict in AudioKit. Making a graph of audio units with high-level Swift objects that's something really valuable for a lot of people. A lot of people want to, just really quick. I'm making a game. I just want to throw stuff together. But yet I feel like here we're struggling to make this really common use case work at that level. And then I feel like, to say, hey, Matt, the solution really is to go implement it in a custom DSP object, push everything all in one custom oscillator, put the whole synth in one audio unit. That's another extreme. That's what Synth 1 is, right?
Well, we discussed this a little bit last time, how kind of operations are a middle ground between the two things, right? So that would be, I guess, the approach is maybe operations need to be built out more so that they're a little bit more capable.
Yeah, but like there are things that could never be put into operations. Like he's connecting this to, like, I think the location of the audio player, right? That sounded like it was scrubbing or something. It wasn't just synthesis, right? You could be doing this to parameters that are Apple audio units or any audio units, whereas the operations only work on the sound sporth based synthesizer-y type of things and effects processor type things. I mean, I think this is an interesting solution. I would like to see, actually, I mean, we can, mark it as dangerous and things like that, but I would like to see this applied to sort of a a cartoon of a synth, like maybe it's not something that Depeche Mode wants to rely on their stage. But if you're like proving out that this is a cool sounding effect and you're using this to modulate your parameters, I don't think it even matters that it's going to like crash in an hour. I think it's kind of cool, and I would like to see if it does crash in an hour. So,
well, I'm only here to inform you what about computer science. Okay, do what you want. You want to make apps any old way. I mean, I'm not a dogmatist. I'm just,
I do really
No.
appreciate your harsh critique, by the way, Taylor. It's very important to get like the, I don't know, the very uncensored, this is what is wrong with what you're doing here.
I don't think Taylor's either
background.
uncensored or harsh. I think he's just matter of fact.
Yeah, well,
yeah.
But I feel like to be fair, I feel like Taylor, a lot of the issues you're raising, it's the truth. But I just feel like what I'm wrestling with is how do I do the best practices you're recommending at a Swift layer, right? Like so many of your recommendations make sense at the C++ layer. If I was just going to live there, it makes sense, right? You know what I mean? So that's a part that I'm wrestling with and trying to wrap my head around.
Well, I guess I just, can't you build an analog synth, virtual analog synth with operations? Excuse me, I don't really know. Maybe
Yeah, I mean, you can
That's
definitely.
a cool challenge. That's a cool challenge.
But that solves a lot of this, right? Like you should be able to do a modulation matrix by connecting like one LFO to a bunch of different things.
Can I ask you something kind of, I'm pretty sure I've already asked it, but just to put it another way, like, is there any thread safe way to go from the audio thread to set any value outside of the audio thread?
Yeah, well, I was talking about that earlier. Like you can use this circular buffer to send data across.
Well, can I just ask, if the only thing I need to do is a callback from the audio thread, how unsafe is that?
So you have a callback.
This is the only thing that's crossing the audio thread. This one, hey, I'm done, callback.
Yeah.
But typically you push that in the buffer and then the main thread will pull it, right? Like you don't dispatch it. That's your sort of indirect dispatch, right?
Yeah, so you would instead of calling lookups complete handler, you'd pass something to the, I mean, you'd have to do this. Yeah. It looks like, so yeah, you're touching self here, self.lfos. So that's gonna run into problems, but
that's, I mean, that's the only way that you could look at, so, I mean, something owns the LFO manager and it needs to know about a callback. So, I mean, I don't know how inside a block you wouldn't have self there.
Well, yeah, I mean,
you know, it'd be interesting there is so like Mike Tyson's circular buffer, and I think you guys approved on this in the last few sessions, had predisposed like Objective-C functions that it would sort of build, and it would pass, elements by value or reference. Like it would build up like an AE array or blah, blah, blah. Here you're just saying, hey, call this callback. And it doesn't look like it's capturing any scope. There's no arguments. So I'm just wondering if circular buffer simply saying, hey, the guy already set this completion handler, but go call it later.
So you can't just do that. You need to, I mean, first of all, you're implicitly sending data across. You're sending this time across. Notice how you calculate next lookup value with real time, right? And then you need to pull that LFO value from elsewhere in order to set stuff. So you can't just have those LFOs just local to this callback, right?
Okay.
Yeah.
So it is implicitly sending data. It's not just sending, hey, update something. It's sending.
Right. I'm hiding the dirty work here because it's not
Yeah, it hides it a little bit. So, side effects and stuff. Yeah, I mean, it's.
So wait, taking a step back, maybe this is super obvious, but I don't think it's ever been explicitly said. There is no Swift code that could be called on the audio thread. There's none, right?
No, this is the audio thread right here, and this is Swift code.
Yeah, we already established that with the with that breakpoint earlier. We saw that it's the remote PIO thread.
Marcus is saying is you shouldn't do it.
Right. Like,
oh, you shouldn't?
Well, Swift, it's not possible, right? There's no way to write Swift that could be called on the audio thread, right? Swift has dynamic or a runtime. There's all kinds of things.
Really not recommended. I mean,
you could, but like it could be allocating memory. It could be, managing scope. It could.
You can look at the LLVM IR and you can see, is it going to allocate memory? Is there any path to allocating memory?
Okay.
I suspect you have to use a very restricted version of Swift in order to avoid that.
I mean, even AV audio source node that he's using, it's Swift, and you can actually create audio. You can make an oscillator in it, right, Pat? So
yeah, absolutely.
Yeah. Okay. Sorry, it's an ignorant question on my part because it just seems like the language has features that could call the runtime. So unless you're super careful not to do that.
Right? Yeah, like as soon as you create an array, for example,
right? Like you're
dynamically allocated. But I think if I don't know, maybe if it's just an oscillator. I mean, it would have to be pretty simple.
Yeah, but
just oscillators, man. We're just looking up values. By the way, I do want to know
if you were to make everything.
Sorry, go ahead.
Oh, just if you were going to make everything static, like if it's a singleton static value of the entirety, like the very top of your class, all of the parameters you access, all of those tables are sort of static or whatever, then you kind of have way less chance or way less likelihood of ARC like collecting any of those things, or somebody having a reference where it's the last reference, and that's where it would dealloc, which is the same as malloc in terms of its danger. And then like at the once you get to the heart of it all, like capturing self is another issue, and it just comes down to like the sort of like the real problem. And if it's not obvious, and I think Taylor, I'm not sure, if I say this incorrectly, just like let me know, but it's the thing is, like, if I write from A to B, right, that's totally fine as long as B is just being read from, and they never do anything else but read from B. Like, so A writes to B, and that's like, and it can go in the other direction, not in the same scenario, but like another scenario, you can, read or write in the other direction. But it's basically like you just want to do a one directional operation. You don't want to be in a situation where you're going to like pick something up when it's not there. You don't want to put something there when someone's trying to get something from there. And it's sort of like,
what is this thing? Is it just float or something?
Thread safety, shared memory is the problem.
So,
and so when you're making, because there's allocation and system calls, right? But there's also shared memory issues, right? Those are the two sort of big things that I would call out.
So there's the real time safety. There's threads, there's basic thread safety. Okay. And then there's sort of another level, which is real-time safety. Here we're not even on the basic thread safety. And I hate to be this guy. I really don't like.
So what is the basic thread safety things? You're saying it's not about shared memory and things being.
It is about shared memory. Yeah, it's
okay.
It's a race condition. I mean, you toss thread sanitizer, started spewing race conditions.
Right. So in the case of like just reading,
data race kind of thing.
Yeah. Right.
So this is where I feel like in C++, it's in your face, like what will cause an issue on the audio thread, like, allocating memory on the heap, like doing a mutex or a block or something. Like, it's in your face. Like, the language is so low level, it's obvious to you. These are the warning signs. You're doing bad things on this thread. This thread's intended for this. You're limited to this. With Swift, there's a lot going on behind your back at the runtime level, and what I'm calling out is like, it'd be really cool if people working at this level had warning signs or guidance about like, hey, I need to use the language this way. I need to not use these features this way. I should structure my program where I pass stuff in by value or blah blah blah. I should never.
Well, I mean, it seems like
yeah.
something for the Swift language designers to work on, I guess.
Yeah. I guess another thing I'm getting at here, though, is like just like pulling back strategic AudioKit is what kind of work do we ever think we're going to be able to do on the audio thread in Swift?
Well, you can create a network of operations in Swift, and then that can you know, be run on the audio thread. I mean, it's not just arbitrary DSP code, but it could cover many use cases. And also, I mean, who knows what the future holds for Swift? You know, I suggested at one point over on the Swift forum about maybe Swift could have some sort of support for real time. I mean, if they can do real time Java, we ought to be able to do real time Swift. Real time Java is a thing, and you know, we ought to be able to do real time Swift. I mean, you know, it's Swift in a sense, it's a better suited for real time than Java. So
yeah, agreed. Anyway. But in the meantime, I feel like for AudioKit 5, folks need to be really aware of this. This is the language as we know it, Swift 5.x, and I could do these things on the audio thread or not. And I feel like for folks like Matt, I'm sympathizing with you, Matt, because I want to keep building new synths and keep doing stuff. And modulation matrices are something I'm super interested in because we didn't do that very good in Synth 1. You know, I need to be able to make a choice. Like, okay, for you know the AudioKit 5 as it is, Swift as it is, Apple as it is. If I need to do something complicated like an audio, you know, matrix modulation, where should I do it? What design pattern should I go towards? Should I just make an uber, you know, monster audio unit and put everything in there like Synth 1? Can I instead work at a really cool level, like a network level with audio units and put them all together? Can we make this, you know, LFO modulation matrix work at that level? I think those are super important, you know, guidances to give to folks who want to use AudioKit. Yeah. And Matt, props to you for like wrestling with this and trying all these different things. Like this is a cool, this approach makes sense, and regardless of its thread safety or not, it's an approach that would make sense for someone who wants to work at that level where I'm working at the Swift level and I want to connect a bunch of nodes together at a high level, you know. And that's like a really powerful use case for AudioKit as a whole, as an ecosystem. Because if I'm like, hey man, I'm just going to make an Uber DSP, then it's like all this cool stuff goes away and we don't wrestle with this. We go down, you know, to that level. You know what I mean? So I just feel like it's like a bifurcation, you know. For anyways.
Well, I took away from last week that if I tried to use a timer, that would not be like sample accurate. So I was like, okay, I know another way that I can, you know, actually know the time when I do my modulations. And so that was part of why I moved in this direction. But like I've done a timer to set these values. Like why not just use a fast timer? Like is that because then I'm not even using the audio thread anymore. I guess like that's one of my thoughts here is like, you know, I'm kind of at a loss as to like why you couldn't just use a fast enough timer, and the difference between like the sample time and where you're at when the timer executes. Like is a timer nothing more than just another thread problem? Or is a timer not like a thread problem because it doesn't interact with the audio thread? It's just its own total different thread. or am I taking us on a tangent here? I want to find, I want to keep digging. I'm deep in the rabbit hole here. I want to search.
Well, I think, should I try to answer that?
Yeah, sorry.
Yeah. So I think, yeah, a timer would be safe. If you just have a timer firing on the main thread doing your modulation, you know, it's going to have some other issues probably with being particularly accurate, I suppose. But, you know, it could be okay. If you don't
And
need to modulate things too fast, then it could be okay.
Then Taylor, how is that different from each time the source node runs through its block, you just asynchronously call the handler? So you're just tossing it away and you
because I'm talking about calling stuff from the main thread, which is the standard use case, not calling stuff from an audio thread and then sharing things between the audio thread and the main thread.
But what if I call the main thread asynchronously?
You mean like a dispatch from within this?
Yeah, so I call the handler and I don't care about knowing that the handler has completed in any way. I just say, go do it, you know, just like JavaScript asynchronous, you know, I'm not awaiting it at all. You know, I'm shooting through the audio thread each time. And when I reach the end of it, I just say, go do the thing if you can keep up.
Right. So, I mean, I don't mean to be pedantic, but the Grand Central Dispatch, I don't think it's real-time safe. But if you don't care too much about that, then you could give it a try. You probably could fix your at least the thread sanitizer issues that way, I suppose.
Just by dispatching this in the main thread?
Yeah, well, maybe. I don't know.
Well, even the call to do the dispatch is going to be maybe not real-time safe, right?
Basically, you need to wrap that whole thing in a call to the main, you know.
What does that method look like? I forget.
Dispatch queue.
Dot main.
That async.
Yeah,
I think
but
you guys
can't just wrap that alone.
But the whole thing from 9.206 down.
Yeah.
I think you guys were alluding to
maybe 2.04.
Wrap the whole thing.
Why can't this stuff be done in the audio thread? Because like things can be done in an audio thread, right? Calculations can be made. Why can't these ones be made? Is this a dumb question?
These are pretty fast. I don't think you'd have any problem with it.
What's that?
I don't think you're doing anything major there.
Yeah.
Is there a lot behind that?
I think so. I mean, like the number of times that gets called per second on the real-time thread is like you're causing a part of the system to do things at a speed that it's not really built to do.
I mean,
at the least.
It looks like the critical question there is calculate next lookup values. The top couple of lines are.
Yeah, that's my go through the LFOs and find your new value in an array.
We don't know what that's doing, right?
So at least that you want to put in the dispatch too.
Okay. And everything else is just what is the time right now, essentially. And if it's the first time, I want to keep track of it. So.
And then Matt, one thing I wanted to say is like even in Synth 1, we had the ability to say, hey, I'm in the audio thread. There's something that happened. Like for example, we keep track of the beat counter at a sample level in the DSP render block. And when we cross that boundary of, hey, I crossed another beat, we say, we use Mike Tyson's, circular buffer he has some stuff on there to just simply call a method on the main, the UI thread at that point. So there are ways within the audio thread to say, hey, go call something on the main thread. Passing data to and from there and making data safe, like that's a whole nother thing. But for simple things like, hey, I crossed a beat boundary, just call this method. I'm not passing data, I'm not modifying data. Like that's a lot safer. Because and I'm only saying this because I think you were alluding to that. You were saying something like, hey, can I just dispatch and from here? And I know this is the right time. Like, can I just go say, hey, go do something? So I think as long as there's not like data reading modification and you just go call a method, like that's pretty safe. But right here, like dispatch main async, that so the way, and Taylor, correct me if I'm wrong, I believe, and I keep hyping Tyson's thing, and I know you guys have replaced it with something more efficient, but Tyson's thing actually here in the audio thread, we would just push onto the circular buffer a message that we know would be read. We're just pushing in the main thread. We're not doing anything. We're not dispatching. We're not calling. We're pushing. We're saying, hey, I'm pushing another message into this queue that I know the main thread is pulling, and will go pull eventually and go construct the right method. So that way the audio thread is actually not allocating memory. It's not doing anything. It's just pushing onto a circular buffer. The next.
I don't think that's any better than just having a timer, really.
Really? So okay, so I have okay. So I'm wrestling with that because it seems to me like timers, like how accurate are they? Like to me, the audio thread's the ultimate timer, right? Like it's the best, right? It's the highest priority.
Yes.
It's got to finish, but it seems like all these other timers and renders.
Okay. Can I just? So you still have to pull from the circular buffer, which means something's has to pull it. And that's going to be on a timer anyway. Therefore, the whole thing is no better.
That's true. You're right.
I do think the data race issues disappeared.
Did they?
Yeah, check it out. So I won't click. It seemed like when I hit the graphic, it freaked out.
All we're seeing is the layout warnings now.
Yeah, that just has to do with my form because
yeah. So this fixes that. It's just
now I want to see that, the left side where they show you like the threads and things.
Oh yeah,
see like the memory, whether that's like doing anything weird.
I should say you probably also have a retain cycle.
Is there anything you guys want to see in particular? Is this gonna drive you guys crazy?
No, it's great. Sounds great.
It's actually a track that I'm about to put out.
Sweet.
So that's good news, right?
Yeah. I think this is pretty useful. I don't think if it's not going to be like drop dead perfect for all synth cases, like that's fine. It's still pretty useful.
So just so I understand what we just did there, like I had said earlier, the first few lines here in this method are just simple calculations. It was the calculate next lookup value that we weren't so sure about. He dispatches them here, and there's a risk that dispatch is not runtime safe. Although now he's playing it, it sounds like it's working. But does that suggest that whatever calculate next lookup value is doing, it was not thread safe here in the audio thread, but it is thread safe in the main thread? Is that what is suggested here? Right, he had all these warnings before, now he doesn't, and the sound sounds very similar.
Yeah, I mean, it's this fixes the thread safety issues, because now it's essentially I mean, it's kind of like using a mutex, really. It's still not real-time safe technically.
Right, because it might not keep up, right? Because the next one could come through when you haven't actually done the calculate and whatever setters.
No, it's simply that, as far as I can remember, dispatch queue is not real-time safe. You can't use Grand Central Dispatch from a real-time thread. So basically you're probably fine. It's just, you know, there are like a bunch of articles and talks that say don't do this, and I hate to be the messenger here, but you know,
I still say all he's doing is changing these parameters. I think it's going to be fine for all practical purposes anyway.
Well, thank you guys for listening to my weird noises.
No, that was awesome. Thank you so much for preparing this.
Yeah.
Yeah, this is really important stuff we're wrestling with here. You know, I think these are really tough questions. So having these kinds of spirited conversations is the right thing to do. Yeah. So what's next for you, Matt? What are you gonna do next? Like you know, this is a little more thread safe. Like, what are you trying to do?
Well, I mean, I would love to make this satisfy, you know, a purist perspective of like what it should be, I guess. But it sounds like the tools aren't there to do that right now on the Swift layer. It sounds like, but I might just not understand like what direction to go from there. So, I mean, like Taylor, would you encourage me to try and figure out a better way to do this with the direction I'm going? Or would you just accept where it's at right now as like that's kind of the best it's going to be if this is what how you're trying to solve the problem?
well, I think you might be better off with a timer, really, just firing on the main thread. I mean, I guess you got to make sure that your main thread is not blocked by other things. So there's that. But I don't know. I mean, because then you're guaranteed maybe your LFO is not super accurate. At least your whole thing is real-time safe. You're doing the proper stuff, you know?
Yeah.
So, I mean, it should be pretty easy for the main thread to keep firing. I mean, unless you've got some big animation or some big transition or something like that.
I just can't understand why an asynchronous call would ever not be real-time safe, because I mean, it's doing nothing, right? It's literally saying someone else do something.
Definitely doing a lot more than nothing. I mean, you can look at the implementation of that. It's quite non-trivial. But you know,
well, as far as like actually doing any of what's inside of it, I guess is what
it's not. It doesn't matter about what's inside of it. It's the queue. It's putting that block onto that queue. You see, that's the issue.
And that you don't think that can happen in a real-time thread ever, I guess.
Well, I mean, I'm operating from memory here, but look, I have to Google it. Is GCD real-time safe?
Because I'd be so surprised that that's like heavier than me doing like floating point arithmetic all over the place in a DSP block.
Yeah, I mean, it's
just like pointing to like but I don't know. I mean, I'm like I said, I'm ignorant over here, but
I mean, I guess I would just start repeating stuff that a lot of stuff you can watch talks about and read about and stuff. I mean, the basic thing is that, you know, let's say you're doing a bunch of floating point DSP work, like you said, that's bounded nicely. So you know it's going to finish in a constant amount of time. You know there's not going to be some system call in there. You're not going to have to wait for some indeterminate period of time. Now let's say that dispatch queue runs out of space or something, needs to allocate some more, and it calls the allocator. Oh, well, then the allocator goes into the kernel. Maybe it needs to mess around with virtual memory. All this stuff happens. It all of a sudden took a lot longer than expected, and your audio gets dropped out.
That makes sense. Yeah.
So, you know, that's how it plays out.
You got to check this link out that I just sent you. Pulled it up on your screen, Matt. This is what when I Google searched it. I click on it. Who answered this question?
Well, I think, didn't I mention that earlier, that I was bugging the Swift people to, you know, add some sort of real-time support, but I think it's, you know, it's probably pretty low on their priority list.
This isn't the first time I've found you like on the web, Taylor, in some sort of audio Swift thing. So I was like, I feel kind of cool just knowing who you are when I run into that. I'm like, hey, I see you too on there, Ari. So it's just interesting to.
I feel like I gotta watch what I say. Damn.
I hate when I Google something and I find myself. It's like I want somebody better.
Yeah.
Oh man. Well, I mean, I was jazzed about this idea, but I was 100% sure that it was gonna have some sort of pushback here on it. So I hate to go back to the timer because that's where I started last week, and we didn't like the timer for the sample inaccuracy, but we can't be sample accurate on the Swift side without real time in safety.
Yeah. I mean, if you really want to, you know, do the Wild West, I mean, I guess you can just say, you know, who cares about thread sanitizer? And
well, we got rid of the thread sanitizer. We just got this asynchronous.
Oh yeah, but now you've
blow up.
I don't think you're gonna get good sample accuracy this way, right? Because this has to wait for the main thread to come around to receive. I mean, it might be okay, but you know, it's yeah.
And that's why the timer makes more sense, because the timer will for sure do something at that moment. Well not for
actually,
sure,
no.
perhaps.
No, not if it's on the main thread. It could still be blocked by something else.
And so this is where I felt weird about a timer, because I'm like, I need some way to at least know what time it is when the timer goes off. I can't just use the timer's interval, because that's going to drift.
I like a lot of things about this solution.
Yeah, I mean, I wish there was someone else here, you know, who's a thread safety nerd as well, to tell me, no, Taylor, you're overlooking something.
I mean, I kind of see this in a way as the audio thread being the timer, and then very, you know, inaccurately maybe, you know, just dispatching calls later. But at least here with this solution with the timer here, you know what the real time is. So when you do make that calculation later on the main thread, whether it's accurate or not, at least you have the real time.
And it could only ever
a real time.
It could only ever be a little late too, right? Because each time it comes back around to the next audio thing, it grabs a new time value.
Yeah.
So at least it's like keeping up, even if it's late.
Well, the other advantage here is that you have a matrix. You have a matrix of LFOs that are being calculated here, not just one. At least they're all being calculated consistently with the same real time, timestamp or whatever it is you're doing. So that's another advantage. Right?
So you're saying say something? You get the go ahead.
I thought Taylor was trying to say something when Marcus was talking, and so.
Sorry, I was just saying you could potentially get a lot of jitter with this solution, I think.
Just because of the dispatch.
Yeah, because it's like it requires the main thread to be ready to go.
Yeah. Yeah, but it would jitter around. I guess that's just one thing you'd have to test, you know, because you don't know how bad that's going to be. Every time the audio comes back around, you know, every time the blocks hit, it's grabbing what is the real time right now. And at least that's right. So we don't know how long it takes to fire, but every time that hits, yeah, it's going to jitter around that. So, and it would only ever be late. So,
Yeah, I mean, you know, test it, see if it's up to the task.
yeah. Well, yeah, I took up everyone's time here, so I'm sorry to kind of, you know.
No, this was better.
Like twice in a row.
Maybe we could, I don't know, do we want to have one other little item?
Sure.
Does anyone want to hear a little bit about Swift UI?
I do.
Yeah. Well, we could talk about the change that I made this morning. And because I think this is like a common, I know I messed this up a lot before I really, it's like a Swift UI, you know, foot gun. If you, Ari, if you could just pull up the change. I'm only going to talk about it very briefly.
Just on the web?
Anywhere, yeah. On the web or in Xcode or however you want to display it.
Okay, I just want to make sure I got this is the change to the cookbook?
Yep.
Yeah. There it is. Okay. You did it in just knob view or no? Hold on.
Yeah, I mean, we can look at any of the files really, the conductors, I guess, or I guess it's all the little views that create the conductors.
Oh, I see. Okay. Yeah. I was just going to pull it up online. A second. Okay, so to share my screen. Oh, just put on the wrong develop.
I see there's a delay view you're working on.
Well, he changed many files because this is the basic change, right?
Yeah, it's really just like a one-liner that I want to talk about.
Yeah,
I mean,
it's there.
The before and after. I mean, can we see a diff?
Oh, sure. Something like this. Basically, observable object turned into state object.
Yeah. Okay. Fine. In a whole bunch of places.
Yeah.
So, does anyone already know this and why you should use state object here instead of an observable object?
Yeah, I learned from Ari, who learned from you. It sounded like whenever I had an issue.
But so state object, if you're going to create a model object internal to your view, then always use state object. Don't use observable object, because if you do it either as an initializer like this or in a constructor, and if you use what is it, observed object, right? What it used to be. Then it's going to recreate it every time. You see, these views are just kind of little throwaway structs. They're like they're recreated all the time. Like something changed in your data model, boom, everything gets recreated, right? And it does it really fast because these are really simple little lightweight things. Okay, but you can't be like recreating data models, or in this case, conductors each time. So what this state object does by some sort of property wrapper magic, it's only going to construct that, you know, for one, like, I guess, one identity of the view. So like, if the delay view is created once, and then the another delay view is created that has the same ID, then it's gonna see this same state object, right? Now, this only happened to work because Swift UI was good. It only happened to work before because Swift UI is good about like not recreating things too many times. But all you would have to do is, you know, have the right kind of change elsewhere, and then you're like, wait, why is it recreating all the conductors all the time? So anyway, that's pretty much all I wanted to say.
Does it still create these all at the beginning when they're put in the navigation view? That's the only thing I didn't like about the cookbook, that all these conductors end up getting created as soon as the navigation view is showing.
Why don't we see? We can put a breakpoint and see when they're created.
Okay, I'll put one in here in the delay. Like creating the body or something, or
like with the constructor for the
conductor. Oh. Gotta get one of those M1 machines so this doesn't take so long.
Yeah, man.
This fixed one of my problems as well, where I had a view recreating itself every time you like change the most basic things about it, like the colors, and all of a sudden, like I had an FFT view where you would like press a button to change the color of it, and every time it would just blow up the whole thing for a second when the color changed, only to find out that every time it was recreating, like you said, the data model. So redoing the taps, everything. So
Boy.
Yeah, I learned that a while ago, but I guess I didn't apply it to the cookbook. Anyone else notice this too? Like when they're launching their apps, ever since like iOS 14, the initial launch takes like 10 seconds extra. I don't know if it's just my machine or not.
I never even used the simulator.
it's a beautiful launch screen though.
Yeah.
All right, so it did not create that delay yet. Now I go here, and it does, so that's good. When it was an environment object, all these conductors were created immediately. So that's an improvement. I don't know why it's not going. There we go.
You mean when it was observable object?
Yeah, I'm pretty sure all the conductors were created right away. I'm not sure.
Yeah, well, that makes sense because it was calling. I think it's just it generates all those view objects. Actually, it's just like this state object is really clever about lazily creating the state object when it's actually needed, I guess.
Gotcha.
So kind of cool.
Yeah. Cool. Use state objects. I've been listening to Swift by Sundell podcasts recently. While I'm biking, I've got these cool. I'll do my advertisement for the Bose headphones, not headphones, but the sunglasses with Bluetooth audio, and they don't actually put earbuds in your ear. It just kind of projects the sound towards your ear, so while you're biking, it's still safe. But I've been listening to this Swift by Sundell podcast, and they have a few really good Swift UI episodes, and people are like, don't use Geometry Reader if you can avoid it. Things that actually I've heard Taylor say in the past too, but nice to hear confirmed by the people interviewed by this guy, Swift by Sundell. So I recommend it. There's a few other tips that he was mentioning that I want to try to incorporate, but maybe I'll gather my thoughts on that in the future. But I recommend the podcast if everyone wants to learn more about Swift UI.
What was the name of it again?
Swift by Sundell. Sundell is John Sundell. He's a Polish Swift developer. He's got an incredibly enthusiastic voice. It's hard to get past in some ways, but once you get past his enthusiasm, it's a really good podcast. Like, he's really happy to interview everybody and really excited about all things Swift, but he knows his stuff.
Sweet.
Cool. Well, thanks everyone. This was really great. I really look forward to getting people who have things to say, because then I don't really have to prepare, which is really cool. But maybe next time, if I know anyone has anything else, I will convert the cookbook to a Swift UI app. That's kind of what I was planning for today, if nothing else came up. So cool.
Thanks.
Cool.
Thanks again,
Great seeing you
guys.
guys, man. Really good
Yeah.
seeing you guys. Take care, everybody.
Appreciate it.
See you next week.